All right, so I'm using a new screencasting software, so this is going to be a little trial run. I hope it works, and I think when you watch this, you should be able to see my head in the lower right-hand corner, like right down there. So there you go. Hopefully this new technique is a winner. So we're going to talk in chapter 11 all about solutions, and we talked in class today about why is the sky blue? And that's a really interesting question and can be talked about in terms of the fact that there's these little particles up in the atmosphere that scatter light. And we can kind of think of the atmosphere as a solution because it's full of gases, but then there's little dust particles and water molecules and stuff like that that allow light to scatter and gives us the reasoning for blue sky during the day and then our sunset colors at night. We're going to talk about the types of solutions in this video. Should be real quick, about 5 minutes. And later on then in the unit, we're going to talk more about why are solutions different? Can we differ their concentrations? And what's an acid and a base? Because those are types of solutions as well, and they're very important types. So let's get started. Types of solutions. We got really 3 classes of them, and the first one is going to be a true solution. That would be like salt water, for instance. The second one would be a suspension. A suspension would be like muddy water, mud dissolved in water. And then the third one would be something called a colloid. A colloid looks like what I'm drinking for lunch right now, is stuff like fine little particles that are suspended in water and that don't settle out. So if I put this little cup on my desk, those particles that are in there making it look like gray wastewater won't settle down to the bottom of my cup. Okay, each one of these solutions are defined by the size of the particles present in the solution. There should not be 2 thes there. I guess I really like the word the when I was creating this presentation. So the larger the particles, naturally, the more likely those particles are to settle to the bottom of the solution. So the larger the particles, the more likely we are to have a suspension. If our particles get smaller, then we're probably going to have a colloid. And we're going to show something called the Tyndall effect, or we probably did show that in class already to figure out if something's a colloid or not. And if we got really super tiny, like sub-microscopic particles, then we're probably looking at a true solution. So let's go through each one of those one by one. By definition, a colloid is nothing more than a heterogeneous mixture in which the particles do not settle out of solution. We've got a couple of classifications of colloids here, different types. More than welcome to write these down, but I am not going to make you memorize these or regurgitate these on a test. They're just rather interesting. So the first one's called an aerosol. So an aerosol is a mixture of a gas plus a liquid or a solid. If you think of fog, fog's a great example of an aerosol because you've got the gaseous atmosphere mixed with the liquid water vapor that's permeating the atmosphere itself, giving us that foggy look. And if you've ever tried to work with high beams, when you're driving through fog, you'll notice that it's not really a good idea. And the reason for that is because of the Tyndall effect. Your high beams are being scattered, so the light is being pushed all around. So if you got fog lamps, which actually push the light down more towards the road, those are your better option. The second type is a foam. So whipped cream, which I eat on pretty much everything, is a combination of a liquid and a gas. An emulsion, 2 different liquids. So milk would be a good example of an emulsion. A sol. This is a liquid and a solid. And paint is actually a really good example of this because paint is a mixture of a liquid material plus solid particles. So total dissolved solids, TDS, will be a number that's often mentioned on the side of paint cans. Solid foam, like a marshmallow, delicious. A solid emulsion, like butter, a solid and a liquid are joined together by the aid of an emulsifier that brings them together in perfect harmony, and you can spread it on your toast. And here I've got a picture of the difference between a colloid and a solution. Okay, so a colloid, which we're talking about on this page, on the left, is going to allow light to scatter. So what I mean by that is if we pass a beam of light through that solution or through that colloid, you're going to see that beam travel from left to right throughout the beaker. On the other hand, if we have a solution and try to pass a beam of light through it, you won't see that beam of light in the solution. It's just going to pass right through without hitting any particles. All right. A suspension is next. A suspension, really super ginormous particles. So if you go out to the beach right outside and you take a scoop of sand and you take some Lake Michigan water and you watch the sand settle out, that's a suspension. So the particles are large enough to settle out. I didn't want to so much think about Lake Michigan water and sand. I wanted to think about an espresso. When I make my coffee in class using my French press, some of the particles of the coffee grounds actually get through my French press screen and they settle to the bottom of my handy dandy coffee mug. And when they do that, they're exhibiting the properties of a suspension. And lastly, true solutions. Now, these are the ones that we'll be focusing on most during Unit 11. Solution is defined as a solute that's dissolved in a solvent so that a homogeneous mixture is formed. Again, the word "the" should not be here. I don't know what it is with "the" today. I apologize greatly. So a solute, what is a solute? A solute is the dissolved stuff. So if you're thinking about like sugar water, sugar is the solute. The solvent is the liquid doing the dissolving. Now, 9 times out of 10, that is water. It doesn't always have to be water. We could use alcohol or we could use gasoline. Just all depends on the polarity of the substance. But more often than not, the solvent in our case is going to be water. And here's a picture of the solvent and the solute to form a solution. So 3 words that we should know. Last page. Here's a description or a depiction of what a solution is. If you take salt, which is an ionic compound built of sodium and chloride ions, when introduced to water, those water molecules are gonna pop the salt crystal apart. See, I actually have some salt right here. The water molecules defined by my hand are just going to go, and they're going to pop the salt crystal apart. Now, these 2 little individual guys are now too tough to see. We cannot see them. When they were together, there was this huge lattice around them, and we could see the crystal. But now that they're separated, can't see them anymore. And so the salt dissolves in the solution, forming a homogeneous mixture, which does not scatter light via the Tyndall effect. So there you go. Those are your types of solutions.